Alright, time for another DraftPhysics.com video presentation. Debate physics also, but no one wishes to argue the arguments, so can't do that part. So anyway, we'll do comments. Should have done this ahead of time, but I didn't. So I have to do this and such. Alright. So I did, well, whatever. It's good. There's comments, so that's excellent. Yeah, that's just something anyway. All right, don't they claim that the single photon, electron, or even proton will interfere with itself in the double slit? Well, experiment. Frankly, they don't do the same experiment, so there's no proton experiment or electron experiment that's actually a double slit experiment in the sense it's not done the same way. They're not randomly shot at a double slit. Okay, so it's all quite a different experiment. Anyway, could you link to a video where you have covered this? Thanks a lot. So the key point is a single photon. All right, so I did go over that in the video just previous to this video you're commenting on, which was called something or other. Yeah, versus Astrum. Your view of light, kind of, but anyway, I'll go over it again, just, with more detail, because it seems like it's stumbling block for people, and I have been over and over it again. I mean, really, there's Veritasium videos where I go over his experiment and point out how he just completely conceded to the fact that it doesn't work. And he basically had to cheat the experiment to force it to work and such. So I've been over this, but anyway, we'll go over it one more time. So they don't use, they always draw it. Okay, this is their part of their line, right? They draw it like, oh, here's a gun and we're going to shoot single photons, and they're going to be like an hour apart or something. They're going to come out of here like one a minute or something. Very few photons. And that's not what they do. Okay, what they do is they create a source of light. Just start over again. Okay, source of light. And, it's radiating in all these directions. And then they just put filters in. Okay. And the filters, as I've tried to explain, are basically just full of little particles, opacancy, and the little particles could be understood to be just another bunch of slits. It's a diffraction gradient, and so the photons go in and the pieces come out. Okay, pieces flying in all directions. Okay, left, right, up, down, all directions. All right, so it just scatters. It scatters. It breaks the light. The photons are going in. They are in phase. They're coherent. And they come out in little sparky little pieces on all kinds of directions. And then they put the two slits in front. They put more than one filter, usually two. So the more filters they add, the more disorganized the little pieces are going to become. And then they put the two slits in, okay. And they have all these little pieces are going into the experiment. So yes, a coherent photon isn't in the experiment at the same time. There's not two coherent photons in the experiment at the same time, but there are tons of pieces. And the simple truth is the pieces do exactly what the regular photons do. That is, they get scattered at the surfaces some more. So they're getting deflected some more. Their path is getting altered some more. And then you just have this, they have exactly the same experiment. You start with coherent light, light that's in phase and organized. You break it into pieces. And so it's the same thing. I could just take this light source and put it here, and I have the same thing in a sense, because once they go through the slits, the only light you're paying any attention to is the fringe light. And the fringe light is always the slit, the surface light. And in this case, obviously, you have some stuff that's already going at an angle. You already have stuff that will go through at an angle. So some of the pieces don't need to go by the surface because they're already incoherent. And so there's never a single photon in the experiment. Now, the big giveaway is they could actually create a photon gun that only produces very few photons. So in another experiment where they do this muon thing, they have a thing called a scintillator. And those are usually just some sort of product that basically takes high energy photons, okay, an X-ray or something, you know, even gamma rays and other rays, okay, ultraviolet light. And you can basically shoot it into different kinds of substances and crystals. And you can basically create an event, a photon. And it'll be rare. So that is, you can put a certain number of, you know, X-rays in, and you can be sort of guaranteed that only 1 in a million will come out as a coherent visible photon. And so you can sort of create a mechanism that only creates very rare photons. And, you know, that's all there are. There aren't a bunch of pieces flying out. All right, and then they could do the experiment. But they don't, like I said, nobody does it this way. Nobody creates a mechanism that's guaranteed to create a certain amount of energy in this field, okay, that isn't passing through this. This isn't absorbing it. So they don't really use a gun. They don't really shoot 1 photon at a time. None of that stuff actually happens. And so the real giveaway was the Veritasium experiment, because yes, he did the regular light bulb kind of idea, okay, put it through an opaque, cause a bunch of scatter, and the fact is he couldn't get the experiment to work if you let it go run for 2 hours, you know, at a certain rate of photons going through. He had to crank it up, okay, so he had to turn an experiment you're supposed to do in maybe 4 or 5 hours into an experiment he did in 5 minutes. And you know, basically the theory is that the only way he'd get the experiment to work is he had to create more stuff coming out of here per second. And without more stuff coming out of here per second, he couldn't get the experiment to work. So clearly he wasn't, even though he was getting real photons coming through here, okay, when he had it dim, you know, when he was doing it at the low settings, they weren't creating any pattern, okay? Because the fact was, yeah, 1 photon would go through here, and then 1 photon would go through here, and 1 photon would go through here, and he wasn't getting 2 photons on these surfaces at the same time. He wasn't getting energy hitting the slits at the same time. And the only way he could get energy to hit the slits at the same time was to crank up the experiment, force it to be a 5-minute experiment instead. Oh, well, you can see most of that. So yeah, that's just, it's all, they can say lots of stuff, but when you actually pick at what they say and actually look at the experiments and how they're done, it's not what they say. Just like the LIGO thing, you know. I think I'll try to find a Degrassi Tyson talking about interferometers, you know, and beam splitters, because this is all stories, okay? You know, and they talk about LIGO like it's, oh, it goes down this 2-mile track and, you know, that's it. When actually they're bouncing it back and forth 800 times. So it's actually hitting a mirror 1,600 times. Yeah. And they're supposed to be measuring the width of a proton with something, you know, the width of a, proton, with, you know, a device that's hitting a mirror 1,600 times. All right. So, yeah, I think that covers that subject. So there is no, when they say single photon experiment, you can't take it seriously, because they're in no way have they eliminated explanations where the counter argument, the explanation that, well, maybe what's coming through that opacancy isn't nothing. Maybe something's coming through, and you have to account for that something. All right, next comment. Oh, it's always something. Stop it. All right, I know this is somewhat off topic, but I have a genuine question I hope you wouldn't mind addressing. I've been watching your videos a few months, and now because you have made sense of physics in a way that removes the mysticism. But there is one thing I just cannot understand. How does your model account for hydrogen? Hydrogen. There we go. Atoms. As you know already, a hydrogen atom is one electron and one proton. Yeah, but hydrogen comes in all these forms, right? Deuterium, tritium, blah, blah, blah. You know, they have, protonium. They have all kinds of stuff. Why does the electron simply fall off the proton within the framework of the magnetic atom? So, all right, well, I'll read the whole thing and then just answer. Perhaps I've already listened to you explain this, but I cannot recall if you have. Just mention the video title since I don't want to waste your time, although in some ways perhaps in asking the question I already have, for which I apologize. Well, it's very kind of you to be this considerate of my time. But, if you have a legitimate, if you watch, these subjects are, there's a lot in them. All right, so the first argument is, do we have any good reason to believe? Look, I'm going to use this argument a lot, okay? This is my favorite argument, okay? When stuff is moving, all right, the consequence is that it's pushing on the environment. So when you move something, now this looks funny to us, right, because of our eyeball, okay? Our eyeball is making things small and making things big. Okay, because we're taking the light into a pupil and focusing it and all that crap. And, the rest of the universe doesn't see the way we see. Okay, it just sees this way. All right, it has rays going perfectly straight across. It sees things in that hologramic kind of way. It sees it as it really is because it's not looking through a pupil. It's not looking through a tiny aperture and creating a focus. So you kind of have to understand that everything in the universe is really built that way, is that things don't change size as they change distance. Okay, this hand doesn't get smaller as these two hands move apart. They're not getting smaller, okay, in reality. So everything's communicating by, moving in the environment. And if we argue that the environment is full of these little bits hitting everything, then obviously when you're moving towards the little bits, you're going to reflect them sooner than they would have been reflected. And when you're moving away, the key point would be is when you're moving away from a source, right? So I'm looking here and you move away. Well, when you're moving away, I'm going to get less photons coming to me because you're moving away from me. So the reflections are going to be delayed, right? Though I would have got a whole bunch of reflections if I stayed here. If I move to here, I'm going to get less reflections. And in the process of moving, I'm going to get even less because I'm moving and the light is moving. And I'm moving much slower, but I'm still moving, which means the stuff doesn't hit me as soon. So the reflections don't happen. And so if the reflections don't happen when you're moving away, that would be what we call... what I could call, okay, the important thing that's happening between something that has a frequency. So something that has a frequency really has stuff and then no stuff. Or it has more stuff and then less stuff and then more stuff and then less stuff. So that's what light's doing. That's what all this radiation is doing. And so every time something moves, if it's moving towards you, it's going to blue shift everything. If it's moving away from you, it's going to redshift everything. So those kind of are those are already known concepts. But it goes further in the sense that blue shifting is compressing and redshift is expanding or lessening. And that's how all these things create patterns. And the patterns are felt by the other objects that feel you vibrating. So everything's seeing everything else. It's seeing its vibration. Your body is seeing the vibrations all around it. Now, you just don't have a sensor that can pick up all those vibrations. And the only one that's sensing anything is this little pupil that's taking in some of these rays and, vibrating inside your retina and creating electricity. But that's the only detector you really have. The rest of you isn't detecting much. if you get it. So there's lots to detect. You just don't have detectors detecting it. You don't have a radio antenna. You don't have all this, you don't have a bunch of whatever chain gear on or something to pick up all the other signals that you're being bombarded with, all the other vibrations. And they're not really vibrations, they're just on and offs, push, pulls, so to speak, in the environment. So that's the first thing to understand, right? So if that is true, okay, so if you can get that part, that particles move in the environment from one place to another, okay, and as they do that, they're going to cause more energy going this way than it's going to go this way when they move. Then you can understand that the Bohr model of the atom that has this electron zooming around, okay, really isn't practical, because then it would be hitting into this field all the time. It would be dragged to a halt, frankly. And it would be creating signal all the time, okay, constantly producing a bunch of pushing in different directions as it went around. So we know that just isn't practical. So yeah, the point would be is that if you're going to think about what an atom is, my argument is going to be is that it's a lot more stable than they claim. So I would argue that the electron is connected to the proton. Okay, they have this relationship. I'd also argue they sort of have to have the same dimensions. Okay, one is just heavier than the other. Okay, because their charge is the same. Their capacity to attract and repel each other is the same, and that really has to do with a surface. It has to do with a density coming off of a surface, frankly. So they have to have the same core, or whatever you want to call it. All right, well, anyway. So, I would argue that when molecules connect, they're just shared. They actually literally share the electron. They're not sharing a theoretical thing, where it just goes in a figure eight. That's the kind of crap they taught in school, was figure eight crap and stuff. It didn't make any sense to me, frankly. How anything would stay connected if most of the time it wasn't very close to the connecting point. So I'm arguing that when molecules do stick to each other, they're actually stuck to each other. The electron is in a position, and yes, the whole molecule can rotate and do things, but it's not a big part of its existence, because again, every time it rotates, it's going to be dragged to a halt. All right. They just don't move through empty space easily, okay, without consequence. Let's put it that way. Without this phenomenon, without having to push on the actual universe. Okay, motion is pushing. All right. So hydrogen. All right, so the problem with hydrogen is you have to go back to how they deduce all of this stuff, and then you have to go through all the experiments and why do they believe what they believe. But yeah, I could make the simple argument that we already know a neutron is a hydrogen. It's a proton and an electron. That's what if they think they have some neutrons all by themselves and they let them sit there, they'll end up with a bunch of electrons and protons and nothing else, I suppose. Like I said, I haven't seen all the experiments they do to make these deductions. And I could argue, okay, that the instability is just in the fact that when it's inside of an atom, okay, it's inside of a whole network of attached objects, so it's very durable. And then taken outside of that, it loses some of that durability. And but the distinction between it becoming something that deteriorates into an electron and proton, or it just being a hydrogen atom, that's the tricky part. So I would argue that the hydrogen atoms are never just hydrogen atoms. It's never so let's just say these get a little bit of motion in that electron. It gets hit and it starts spinning. Okay, it starts doing something, all right, that makes it a little more vulnerable to the two things being separated. All right. So you have an electron. But let's just go with the simple part. You have an electron and a proton, and we understand one of them's positive and one of them's negative. So this is supposed to be hydrogen. And I would argue that the electron can be a lot closer to the nucleus than they say. They don't. There's no rules here where they've done some, where they've taken real video of an atom and decided the electron has to be 17 miles away. But regardless, let's just say it has this formation as a hydrogen atom. Well, the fact is, though, it could do this, okay? And it's still hydrogen, right? So I can just do this. So I just take two hydrogen atoms and stick them next to each other, and they combine very simply into this easy structure. And I can also just combine them by putting another one here and another one here, right? Negative and positive. And so this thing they call a deuteron. So I mean, it's really complicated in saying what are they actually, when you have a bucket full of hydrogen, what form is the hydrogen actually in? I mean, obviously I'd say when it's liquid hydrogen, the molecules aren't free, okay? There's not a bunch of little, this, and then there's one over here, and there's one over here. That's not what it's doing. And I'd say when you have hydrogen gas, it's not even doing that. Okay, when it's hydrogen gas, it's really this more complex arrangement of hydrogen, where you have the capacity to attach to this whole hydrogen and separate the two molecules that are stuck to each other. It's like gold, right? You can have one atom of gold, or you can have 10 atoms of gold, or 500 atoms of gold, and they're going to tend to stick to each other. But it's still gold. You can still knock one atom off pretty easily. The bond isn't that strong, or you can't break it. And the interesting thing is you could break it two ways, right? You can break it this way, or you could break it that way, and you'd still have one hydrogen atom. So, I mean, there's hydrogen 1 and hydrogen 2 and hydrogen 3, and, it gets kind of complicated. And I don't know how, without going into all whatever experiments they do, figuring out when they make these distinctions between hydrogen and a neutron. So you could say all the atoms are made out of hydrogen. I mean, I could say it certainly. Because they all contain a bunch of neutrons, and the neutrons are just hydrogen, with the electron and proton a little closer together. So you could say like a neutron star is kind of, the whole thing it's doing is that it has this hydrogen in this very compact state. So the electron and the proton are very close to each other, so there's very little space, involved. So that would sort of be, I guess, the key difference is the neutron, the two things are really close to each other, and in the hydrogen atom there's a distance because the electron has some motion. And the motion is enough, whether it's just vibrating motion or not. I mean, obviously, if you add the proton, if you add a neutron to hydrogen, the neutron is just another hydrogen. So again, it just depends on how you add it, and it'll just cause it to be able to vibrate. But in certain configurations, you can understand that its vibrations will be limited, right? So if I have a single proton and then I have two electrons, you can understand that the two electrons can't go any further than this kind of arc in terms of vibrating, because they'll keep seeing each other, and if they see each other, they're going to get pushed by each other. So they can only oscillate, vibrate in this kind of way. Well, you see most of that, right? Most of it. So it's not like it's really complicated. In terms of, I think it's made out of something just this kind of simple, but it goes through all these stages of just all you need to do is really change the distance, right? So all I'm saying is that you could theorize that the neutron is very compact. That's why a neutron star would be insanely heavy, is because you've taken all the extra space out. So for a given amount of space, you have 1,000,000 times more weight because you have more electrons and protons compacted in the neutron star, because it isn't messing with a bunch of other atomic structure. It's just a bunch of dense hydrogen, you could argue. And then, when you take it out of a nucleus, then there's more motion, and as there's motion, the average distance between the electron and the proton gets larger and larger, you could argue, and because of the complexity of its environment, or how much motion it has. Because this is much heavier. So the argument would be this is heavier. Now, I don't know whether it's 100 times heavier or 1,000 times heavier. They say it's 2,000 times heavier. I don't think that's true. Those experiments just have to do with how hard it is to pull it from something, and what you're pulling it from is really, you have to understand what you're pulling it from to understand how much work you're doing. How much is its real weight, and how much work it is to pull it away from a surface that has electrons in it. Pulling a proton from electrons is a lot harder than just pulling a proton when there's nothing else around. And it should be understood that none of these particles can exist almost in any environment you could imagine, unencumbered by attractions and repulsions. I mean, no matter where they are, there is some direction that is a bias. It's very hard to isolate them. You have to use pretty strong magnetic fields to create an environment where you can force them not to move, because they're always going to see a weakness, a place that's a little bit more positive or a little bit more negative. And all it has to be is a little bit, and they're going to move in that direction. So anyway, that's really, this is a neutron is a small amount of space, a hydrogen is more space, but the trick is it can be more space in a configuration that is associated with other hydrogen atoms. And the hydrogen atoms will, they'll find arrangements. And again, you can have an arrangement where you have a proton and 2 electrons, and it becomes kind of interesting how it reacts in the world, because if it goes in a direction, the 1 electron can get hit by force that will push on it, but the second electron can't, because the first electron absorbed all of that energy, and any energy that goes through all of them just ends up being mute, because the electron changes the electron force, changes the proton force into electron force. The proton changes the electron force into proton force, and the electron ignores that. So there would be no wind here and wind here. So any momentum this electron has, it would have a hard time losing. All right. You have to lose it because you have to interact with it in some other direction. So it has to be a material that's capable of being affected, changed by it bumping into other atoms. It has to be in an environment where it's pushing other atoms for you to change its the momentum of that electron in the back. All right, anyway, so that gets into this whole drag argument, so kind of more complicated. But that's the best I can do right now. I mean, you could spend pretty much a lifetime probably examining all the different experiments that have been done regarding hydrogen and how it behaves in different environments. And obviously, I haven't gone through all of those experiments. What the hell? There's only 3 comments showing. I don't know what's going on here. Come on. Come on. What the hell is that? Broken. It's always something. There are more comments. They're just not going to show on this page. That's okay. Anyway, just funny. Oh, you can't see that anyway. You really didn't need to see the comments, but it is strange. It won't scroll. Look at that. See? It won't scroll. It's not showing the other comments. They're gone or something. Top comments. I didn't say top comments. Newest first. Let's see if that fixes it. No. published. Yeah. It's just really sorry. It just kind of amazes me every time YouTube does something stupid. And you're just like, how the hell? And where's the mentioned thing? The mentioned thing is gone. Ah, okay, it's doing comments on just this video. Okay, that's where it got broken. Alright, so then I have to go to comments. Okay, then it gets fixed. Ah, I see. Alright. So, Superior Mind did leave a comment about ways of understanding that we're in this sea of energy. And so I'll just read that part. By the way, I just realized the visual way to explain to people the surrounding bubble of the universe in effect. So basically, anywhere you are, you have rays of force coming from stars around you. Any point you choose to look at, somewhere along that path, you'll come across something that's emitting force in your direction, which is how we can see it. Yes, and it's all kinds of forces, right? I mean, all kinds of radiation is coming off of, reflecting off of anything. Right now I'm reflecting some microwaves, I'm reflecting all kinds of stuff. And stuff is going right through me, and then being emitted is maybe infrared radiation. So all that stuff is photonish, and it's theoretically can move pretty readily through space. Now the tricky part is the atmosphere, right? Because it changes the game. Like microwaves, they're pretty high frequency. You'd almost say you should be able to get some detail with them. And then when you go to infrared, they're even higher frequency, so they're even shorter wavelengths. You should be getting even more information with infrared. But the problem is that microwaves start to give you an indication of the problem, because the microwaves are already starting to vibrate water. All right, and the problem is that the atmosphere is full of water. Okay, even though it doesn't seem like it's full of water, it's full of water. And the microwaves, the infrared radiation is moving the water. It's heating it. It's heating the atmosphere. So you can't make a really great infrared camera because you can't see through the atmosphere. So without the atmosphere, it works pretty good, but in atmosphere, it doesn't work so good. Because your information is getting fogged by the atmosphere. The atmosphere is just essentially a fog in the way of the infrared radiation being transmittable in a complete form. So that's sort of an interesting part of that whole conversation, is the fact that we do live in this atmosphere and we don't see the universe the way it really is. Okay, we see it as it's been distorted by the filter of the gases in the atmosphere. So anyway, let's see. So shape of a sphere. So essentially there is a sphere in effect whereby force is returning to us from the stars and such, and a unique sphere for each person in effect, like each individual atom anywhere. So yes, every place in space is being hit. And you can understand that two spaces that are next to each other are likely getting hit by pretty much the same stuff. And so they have the same condition. Unless you change something about them internally, the external world isn't going to provide a distinct difference. But the fact is that everything is in a unique position, and there can be, one extra photon that hits you that doesn't hit me, kind of thing. But anyway, all right, so thanks for that and such. All right, so that's probably enough. And well, maybe I'll just check the website. I don't know, I haven't bothered because people are just so rude. But I'll go look for the hell of it. All right, well, there's something here. The first comment's just all kinds of cunt, bitch, motherfucker stuff. This one says, your no true Scotsman fallacy is classic. They aren't doing any real experiments. So you can't make an argument, right? So that's their argument, is they're going to defend this really poor science. And they just keep doing it. I'm just sitting here pleading with you to say, okay, can't you concede anything here? You can't You can't concede that they really should have repeated the Eddington experiment by now. I mean, they're using 1919 results, and there's 400 times better resolution from space, and you're not going to take advantage of that and do the 5-minute experiment that you don't need an eclipse to do from space. I mean, these are real arguments that these experiments suck. You don't have any experiment showing it taking 4 times the fuel to go twice as fast, or any experiment showing 4 times the energy or joules or heat or watts being produced by something going twice as fast. So you have nothing. I mean, the experiments absolutely are. The pool of evidence is dry as a bone, frankly. It's got cactuses growing in it. And here you are arguing as if, oh, you're just such a cheater to sit there and complain that we haven't. I mean, it's amazing that you can be this dishonest. I mean, you're just making my arguments all the more credible by being so incredulous, okay, in denying simple truth that, yes, you would agree that it would be better if they spent a little tiny bit of money to do these elemental experiments and prove what they claim to be true. If you're going to claim light is twice as bent by gravity, and you in fact can take a video of it, you sort of have the obligation to take the video. I mean, if you're going to claim somebody's walking on water, it's really not a big deal to point your cell phone at it and take a video. All right, the ones that prove me right, everything else is bogus, so just more nonsense. I'm claiming it would be good to have the experiments done well, okay? And they think that I'm supposed to think that any frickin' amateur crap, plastic cart bullshit experiment is supposed to be proof, and we don't have to worry about the fact that it's a contradiction of your own physics. I mean, I can play the Professor Lewin quote over and over again. You have a real duality problem, and you're pretending it doesn't exist. That it's perfectly fine to have some silly duality. Two energy theories. I mean, it makes no sense. All right. Reality is bogus unless it does what I say. So just more nonsense. That's not my argument. Let's see. So this long-haired I don't even know what that is. Tardarosaurus is still trying to convince people of his genius. Ha 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 ha. Yeah, great comment. I mean, it's just so stupid. And then they had put up a link to terminal velocity. What does that have to do with anything? Calculating terminal velocity. What does that have to do with any of these conversations? Then they publish my name, blah, blah, blah. Talking about some sort of poo eating. I mean, it's just such a... Now, we can report your channel and get you taken down off the internet. I mean, what the fuck? Ooh, they're threatening me. Ooh. God damn. Oh, what sacks of shit, are defending science. The garbage, the human garbage that shows up to defend science. Amazing shit. And why? I mean, it's not supposed to be a religion, it's not supposed to be some sacred thing that you can't have defiled. Oh, and again, just how many voices are out there doing any critiquing or any scrutiny at all? I mean, just about zero. And they can't tolerate just this little peep, one little bird making one little peep, and they're all in a panic. I mean, it's pathetic. Absolutely pathetic. All right. So, enough of a video. Till the next time and such. Blah, 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 blah. Ugh, people. Hate them. Hate this planet. Just can't stand it here. But I have to. So, I guess that's what I'll do until dead.